Welcome back, everybody. We are going to work on section 1.6. The part of this section that we're going to focus on is equations in quadratic form. Please enjoy the kitty cat as well. We've already talked about this slightly, but basically what we're doing is we're using substitution. We talked about substitution back in R.4 and how we can use substitution to help us factor. And in this case, we're going to use substitution to help us solve. So we want these to be in quadratic form. We can use one of our methods, factoring, completing the square, quadratic formula, to be able to solve. And then we have to put our values back in that we substituted. Remember, you can use any letter you want except for I, because we remember now that I is the square root of -1, and we don't want to use whatever variable is given in the problem. And so if I'm looking at my B term, that's usually the value that we're going to substitute, x plus 1 to the 1/3 power. And so we can pick any letter we want. Let's pick R. Let's say that R is x plus 1 to the 1/3 power. There's a 1 in front of this. There's a 1x to the first here. So r squared minus, we bring that down, r, you can write r to the first, minus 2 is equal to 0. We take a look at our new equation and we say, well, is there a greatest common factor that I can reduce everything by? No, because they're all prime numbers. Is it equal to 0? Yes. We have a choice. We can try to factor this, or we can put it into quadratic formula. I'm going to factor this. 1 times -2 is -2. The factors of -2 that add to -1 are -2 and +1. So if I write this out, that's going to be r squared minus 2r plus 1r minus 2. This is where we're using our factoring by grouping, and we split that in half. Our common factor on the left side is r. That leaves us with r minus 2. The right side starts with adding. And remember, when we're factoring by grouping, we always have to pull something out, even if it's 1, because 1 is always a common factor. And in this case, we'll pull out 1. And that leaves us with r minus 2. These r minus 2's being the same tells us we've done our factoring correctly, and also tells us that our new common factor is r minus 2. R plus 1 is what we pulled out, and we're setting that equal to 0. From here, we're saying that these two factors, r minus 2, set it equal to 0. R plus 1, set it equal to 0. Solve for r. The opposite of subtracting 2 is adding 2 to both sides. So we have r is equal to positive 2. The opposite of adding 1 is subtracting 1 to both sides. And we have r is equal to -1. Remember, our original equation had x, not r. R, we said, is equal to x plus 1 to the 1/3 power. And that's where we're going to take these two answers that we just got next. We have r is equal to 2. If I replace r with the x plus 1 to the 1/3, then we have x plus 1 to the 1/3 is equal to 2. The reciprocal of 1/3 is 3. So we're raising both sides to the 1/3 power. 1/3 times 3 is 1. So it frees that x plus 1. 2 to the 3rd power is 8. Subtract 1 from both sides, and we have x is equal to 7. So our first solution would be 7. We have to take that second answer that we got, the r is equal to -1, and do the same thing. If r is equal to -1, x plus 1 to the 1/3 is equal to -1. Again, the reciprocal of a third is 3, so we're raising both sides to the 3rd power. 1/3 times 3 is 1, so it frees that x plus 1. -1 to the 3rd power is -1. The last step to getting x alone, we're subtracting 1 from both sides, and we get x is equal to -2. So our solution set is 7, -2. For letter B, our B term is x to the -1st. So let's say W is equal to x to the -1st. What that basically means is we're dividing each of these by -1, which makes that 6x to the +2nd plus x to the +1st is equal to 2. Well, I can't do, oops, I forgot we changed that to W. My apologies. Those are W's, not X's. W and W. All right. I can't do anything with this in terms of factoring or quadratic formula unless it's equal to 0. So my first step would be to bring that 2 over to the left side. That gives us 6w squared plus w minus 2 is equal to 0. We have this in standard form. We check for a GCF. Is there a GCF with 6, 1, or -2? No, there really isn't. So your choice now, are we going to factor, use quadratic formula, or completing the square? I love factoring, so I'm just going to go ahead and factor. 6 times -2 is -12. The factors of -12 that add to +1 are 4 and -3. Writing this out, we would have 6w squared plus 4w minus 3w minus 2. We are splitting this in half. Our greatest common factor on the left side is going to be 2w. Leaves us with 3w plus 2. The right side, we pull down that subtraction, and our greatest common factor here is 1. Remember to be careful with your signs because that means that we're dividing both of these by -1. So we get a positive 3w and a positive 2. That's great because that means that my parentheses are exactly the same. We factored correctly, and that's also our first common factor. And then we pulled out 2w minus 1. And a reminder that all of that is equal to 0. Now we can take each of those factors, set them equal to 0, and solve for x. 3w plus 2 is equal to 0. 2w minus 1 is equal to 0. Solving, we subtract 2 from each side. 3w is -2. Divide by 3. And w is -2/3. 2w minus 1, we start with adding 1 to both sides. And then divide both sides by 2. W is 1/2. But wait, there's more. We still have to get our original x back into that equation. So now that we know w is equal to negative 2/3, we replace it with the x to the negative first. So x to the negative first is equal to negative 2/3. Remember, we need a positive 1, so we want to take it to the negative first power. Exponent rules say that we would multiply these two together, so negative 1 times negative 1 is positive 1. This negative 1, remember the job of a negative is to take the reciprocal of whatever it's being applied to. So the reciprocal of negative 2/3 is negative 3/2. And again, you can always plug that into your calculator and it'll give you that same thing. So one of our final solutions is x is equal to negative 3/2. So we do the same thing with w is equal to 1/2. W is really x to the negative first. Take both sides to the negative first power. So we get x to the positive first. We do the reciprocal of 1/2, which is 2. So our two solutions in our solution set are negative 3/2 and positive 2. Another example, you can do this using substitution, but you don't have to. We can do this with regular factoring. So let's take a look. Is it equal to 0? Yep. We have 12, 11, and 2. Greatest common factor? Nope. 12 times 2 is positive 24. The factors of positive 24 that add to negative 11 are negative 8 and negative 3. Remember, the two middle terms take on the variable that's in the middle because I have to add to that. So we have 12x to the 4th minus 8x squared minus 3x squared, and then we bring down that plus 2. Split that in half. Our greatest common factor over on the left side is 4x squared. That leaves us with 3x squared minus 2. The right side starts with subtraction. Remember, we always have to pull something out when we're factoring by grouping. And in this case, our greatest common factor is going to be negative 1. Remember to be careful. That means you're dividing the right side by negative 1 and changing the signs to a positive 3x squared and a negative 2. This is perfect because those two parentheses are equal to each other, and that's our new common factor. We pulled out 4x squared minus 1. And remember, all of that is still equal to 0. Now that I have these, we can start with the solving. Remember, we take each parenthesis, set it equal to 0, and solve for x. The opposite of subtracting 2 is adding 2, so we're adding 2 to both sides. Those add to 0. We have 3x squared is equal to 2. The opposite of multiplying by 3 is dividing by 3. 3 over 3 reduces to 1, so we have 1x squared is equal to 2 over 3. Remember, we really don't use decimals unless they specifically ask us to, so we're leaving that as 2/3. The opposite of a square is taking a square root. We personally wrote the square root down on our paper, so we start with a plus minus. And I work with the square root of 2 first. Can I take the square root of 2? No. Can I simplify it? No. Do we need to pull out an I for a negative? No. So the square root of 2 stays. And then we look at the 3. Can I take the square root of 3? No. Can I break down the square root of 3? No. So the square root of 3 stays. Now in this case, remember we're not allowed to leave a square root in the bottom. So we have to rationalize the denominator, which means whatever radical the denominator is, we have to multiply both the top and the bottom by that. Doing that, 2 times 3 is 6. 3 times 3 is 9. Now, I can't do anything with the square root of 6, but the square root of 9 is 3. So there are 2 of our answers of our solution set. And remember, I say 2 because that's a plus and a minus. So that's technically 2 things. Over here with the 4x squared minus 1, we start with adding 1 to the other side. We have 4x squared is equal to 1. Divide by 4. 4 over 4 reduces to 1. And 1/4 I really can't do anything with, so we're going to leave it alone. The opposite of a square is a square root. So we have x is equal to, we personally put that square root on our paper, so I'm putting a plus minus. Square root of 1. Square root of 1 is 1. Square root of 4 is 2. We took the square root, so we don't write the square root symbol any longer. And plus or minus 1/2 are the other 2 answers. This takes care of section 1.6. Thanks so much for joining me today. See you tomorrow.